1-meter concrete roof on top of the Launch Control Center. Just at the bottom of the top you can see there, you can see the mast. Can you see it just attaching to the top, that big grey mast? Now, he's just announced that the umbilical lines, which are inside that mast, have now been detached. They fall into a little basket inside the mast. Those lines are the feed lines, taking the services, the electrical services, the air conditioning, etc., to the upper parts of the launcher. And then there's another mast below it, which contains the feed lines to the lower parts, and both of those will be retracting just before launch. Now, everybody is going outside to watch the launch from the 2 terraces, so they can see it with their own eyes and feel the power of the beast as it flies over. Now, a quick word about the ignition sequence. We switch the engines on 16 seconds before launch. That gives us time to throttle up slowly to make sure they're working properly.
À tous de DDO, attention pour moins 1 minute. Top, à 0 moins 1 minute.
We are 1 minute to launch, and we are orbiting the next 4 satellites in the O3b constellation, which Thales Arianespace built for SES networks. And we are flying on board the 22nd Soyuz to launch from the Guyana Space Center. We're 40 seconds to launch. Soyuz switching to onboard power. Let's watch.
Lagage du Mac KZM. À tous de DDO, attention pour le début de la séquence d'allumage du lanceur. Top, à 0 moins 20 secondes. Lagage du Mac VKM, allumage triétage. À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top, décollage UVS 22. La propulsion est nominale.
We are off. The next 4 satellites in the O3b constellation have started their journey. Our cameras following the launcher there as she lifted off from the pad here in the Amazon rainforest. He's telling us that everything is going according to plan. Those 4 boosters are doing all the work right now. They're hauling us away from the gravity of our planet. They burn for a couple of minutes, but that's enough to get us away from the pull of Earth.
La propulsion est nominale.
And their propulsion is normal. Nominal means normal. Bottom left-hand side of the screen, 37 kilometers above the Earth right now and climbing. This is the scheduled moment for the boosters to be jettisoned. And that's what it looks like up there. Cameras on a previous launch. See how they twist and turn? That's all planned.
Séparation des boosters.
And that's been confirmed. We have separated our boosters. And I can hear the sound of the Soyuz here now over the Mission Control Center, which is about 20 kilometers from the pad. It takes a while for the sound to get to us. Trajectory on the top right-hand side, the planned trajectory is the yellow curve, and the cross is the actual position of the launch vehicle. You can see that we're climbing. Our distance in the middle of the bottom of the screen is the distance from the pad if you were to draw a straight line from the pad to the position where the launcher is. And then our speed on the bottom right. Speed on the bottom right is our speed per second, kilometers per second. We're traveling at 2.19 kilometers per second. As we turn around, we're getting a good shot here of the fairing. That's the top of the launch vehicle, and inside there are our satellites. It's protecting us from the rigors of the launch, various things, the sound at liftoff, the acoustic vibrations at liftoff. Don't think you need me to tell you how loud that is.
Le lanceur est stable.
He's telling us the launch vehicle is stable. And also, of course, friction, because if you look at the bottom right-hand side of the left-hand side of the screen, we are now 120 kilometers above Earth. Until now, we've been flying through the dense part of the atmosphere, but we no longer have friction because we are in space. So we can jettison our fairing.
Séparation de la coiffe.
And that's now been confirmed. We have jettisoned the fairing, and we can see our satellites for the first time. The 4 O3b satellites at the front attached to their special dispenser. And in the middle, can you see a gap between the third stage and the second stage? Well, that's there on purpose with the lattice area. That's because Soyuz uses what's called a hot stage technique. It switches on the engine of the third stage while the second stage is still burning, and that allows the evacuation. So,
Séparation bloc A.
And we have confirmation there that we've now separated the second stage, the block A, and we have jettisoned the rear section. So we are now burning the third stage, and our flight path, you can see it there. We're traveling along the equator, so we've lifted off from the pad. The Galileo is the tracking station here at the Arianespace Center. And the next one to pick us up will be the Natal tracking station. These computer-generated images are a simulation of what the experts have planned. And it's what they've calculated is happening to the launcher and the satellites.
La propulsion bloc I est nominale.
The propulsion's normal. So basically what they do is they take all the information, all the data, and all the schedule of events that is based on extremely accurate predictions, dedicated. I didn't get a chance to read it. If he puts it up again, I shall translate it for you. They put all of that into the computer, which then generates these images for us and allows us to visualize what's happening up there in space. Because, of course, what happens in space is something we can't actually see with our own cameras.
Les paramètres à bord sont normaux.
We lifted off from the pad 6 minutes and 52 seconds ago. It was a spectacular launch. The 4 O3b satellites lifted off in style in their first-class compartment with their seatbelts on. on board the 22nd Soyuz launch vehicle to lift off from this pad here, the dedicated pad at the Arianespace Center.
Acquisition de la télémesure pour la station de Natal au Brésil.
We are now entered into the tracking zone of the Natal ground station. The range operations manager has just confirmed that Natal have picked us up, so you can see it there. It's on the northeastern coast of Brazil. The tracking stations, often known as downrange stations. The range is the spaceport, but also all the other associated buildings across the planet which pick up the signal as we fly over. And this allows us to track what the launch is doing in real time, but also to check afterwards, make an evaluation. And Soyuz, for Soyuz, the flight data from the rocket does go via Moscow first to be validated. Sometimes it can take a little time for us to get confirmations. But we're seeing key moments happening at the scheduled time. Telemetry is also known as telematics. Telemetry, of course, being the name for the process of sending the signal to the tracking stations. We use telemetry. And it's a technology which allows measurements to be taken from far away. It actually comes from the Greek, tele, which means remote, like television or telemedicine, medicine from a distance, and metron meaning measure, so measurement from a distance. It's used in a lot of industries, oil and gas, for example, medicine, healthcare, mining. So this is the scheduled separation now of the third stage, and that's what it looks like up there.
Séparation frégate.
And we have that confirmed by the range operations manager. We've separated the third stage, and we are getting close now to the next phase of the journey where the upper stage will take the wheel. It's preparing to switch its engine on. This is called the pre-burn phase, giving a quick burst of acceleration. You can't really see it, but it's pushing the fluids back into the tanks. And that's to make sure that there is enough propellant to ignite the engine properly. It's a bit like when you press the accelerator in the car and you suddenly speed up and you get pushed back against the seat. This is the scheduled time then for Frigate to switch its engine on for the first burn. Its job being to deliver our satellites to their drop-off point in space.